Welcome to Training Configuration. This lesson is part of Module 04, First Fine-Tuning Project. Let's get started. Let's now look at Lesson 4.3, Configuring Training Parameters. Here we can see the LR schedule comparison. Let's now look at Overview. Here we can see the LoRa rank comparison. Training parameters can make or break your fine-tuning results. Too high learning rate, model diverges. Too small batch size, training takes forever. In this lesson, you'll learn to configure training parameters optimally for your Tesla P40 GPUs. Duration, 45 minutes. Difficulty, intermediate. Let's now look at learning objectives. Here we can see the gradient accumulation. By the end of this lesson, you will understand key training hyperparameters, choose optimal learning rates, configure batch sizes for Tesla, P40, set up gradient accumulation, configure warm-up and learning rate scheduling, enable memory-efficient training on Windows, set up logging and checkpointing, and let's now look at key training parameters. Here we can see the hyperparameter sensitivity. Let's now look at the big 5 hyperparameters. Here we can see the warm-up schedule. 1. Learning rate. How big each update step is. 2. Batch size. How many examples per update. 3. Epochs. How many times to see full dataset. 4. Warm-up. Gradual learning rate increase at start 5. Scheduler. Learning rate changes during training. Let's now look at learning rate. Here we can see the rank versus quality. Let's now look at what is learning rate. Here we can see the optimizer comparison. Learning rate, show step size for updating model weights. Too high, model diverges, loss goes to infinity. Too low, training too slow, might get stuck. Just right, steady loss decrease. Let's now look at recommended learning rates. Here we can see the batch versus grad outcome. Let's now look at for LoRa fine-tuning. Here we can see the learning rate finder. Model size, learning rate, notes. 1.3b params, 2E4 to 5E4. Higher is fine for small models, 713b params, 1E4 to 2E4. Standard range, 30b plus params, 5E5 to 1E4. Lower for large models, for Llama 323b with low rank adaptation, start with 2E4. Let's now look at learning rate scheduling. Here we can see the config quick reference. Scheduler changes learning rate during training. Common schedules. 1. Constant. Same LR throughout Python LR scheduler. Type charged constant. 2. Linear. Gradually decrease to 0. Python LR scheduler. Type linear. 3. Cosine. Smooth decrease curve. Recommended Python LR scheduler type tree de cosine. For this module, use cosine. Let's now look at batch size. Let's now look at understanding batch size. Per device batch size, mesh examples processed per G, PU step. Effective batch size, mesh per device, batch dot size, X num dat GPUs, X gradient dat accumulation dat steps. Let's now look at Tesla P40 recommendations. For Llama 3.23b, 4-bit, average 200 tokens example, config, VRAM usage, speed, recommended. Batch 1, grad Axiono 1, byte 8 GB, slow, too slow. Batch 2, grad AC4, byte 10 GB, good, safe start. Batch 4, grad AC2, showing 12 GB, better, good balance. Batch 8, grad AC1, to 16 GB, best, may on long sequences. Start with batch 4, gradient accumulation 2, effective batch minus 8. Let's now look at gradient accumulation. Why use it? Simulates larger batch size without memory cost. Accumulate gradients over n steps, then update weights. Effective batch size, Stu-X4, right. Rules, effective batch size, 832 is good for most tasks. Larger batch mature, more stable, but risk of overfitting on small datasets. Smaller batch, more noise, often generalizes better. Let's now look at epochs and steps. Let's now look at what are epochs. Epoch solves you as one complete pass through entire dataset. Example, 100 training examples. Batch size 4, 1 epoch, 104, 25 steps. Let's now look at how many epochs. Dataset size, Recommended epochs. Notes. 1050 examples. 1020. Small data. Need multiple passes. 5200 examples. 35. Standard range. 200. 1000 examples. 23. Larger data. 1000 plus examples. 12. Large data. Risk overfitting. For 100, 200 examples, use 3 epochs. Let's now look at max steps versus num epochs. Here's the Python code for this section. Starting with num train epochs 3, such as train for 3 full passes. Overrides num train epochs. For this module, use num train epochs of 3. Let's now look at warm-up. Let's now look at what is warm-up. Warm-up shall gradually increase learning rate from 0 to target. Why? Prevents early instability, helps model adjust to new task. Standard practice in fine-tuning. Let's now look at warm-up configuration. Warm-up steps. Number of steps to reach full learning rate. Rules of thumb. Short training, 500 steps. 5-10% of steps. Medium training, 500, 2,000 steps. 10-20 steps. Long training, 2,000 steps. 100, 500 steps. Example. Total steps, dataset size, batch size. X epochs, for 120 examples. Batch 4, 120, 4. X3 are just 90 steps. For 100, 300 total steps, use warm-up steps 10. Let's now look at complete training configuration. Let's now look at recommended settings for Llama 3.23b. Output training schedule, batch size and accumulation, learning rate, optimization, precision. Let's now look at optimizer choice. Let's now look at AtomW 8-bit, recommended for Windows. Here's the Python code for this section. Starting with optim.atomw 8-bit. Benefits: 75% less memory than regular AtomW, minimal quality loss, works great on Windows, perfect for Tesla P40. Let's now look at alternatives. Optimizer, memory, speed, quality, Windows. AtomU 8-bit, low, fast, excellent, best. AtomU Torch, high, fast, excellent, works. SGD, very low, fast, good, works. Ada factor, low, slow, good, works. For this module, use AtomU 8-bit. Let's now look at monitoring and logging. Let's now look at logging configuration. Here's the Python code for this section. Starting with logging steps 10. Shall log every 10 steps. What gets logged? Training loss, learning rate, gradient norm, steps per second. Let's now look at evaluation during training. Here's the Python code for this section. Starting with eval strategy, steps, set, evaluate periodically. What gets evaluated? Validation loss, perplexity, optional. Why evaluate during training? Detect overfitting early. Choose best checkpoint. Stop training if validation loss increases. Let's now look at checkpointing strategy. Let's now look at save configuration. Here's the Python code for this section. Starting with save strategy steps. Save checkpoints during training. Checkpoint includes model weights, low rank adaptation adapters, optimizer state, training state, random seed state. Storage, low rank adaptation. Checkpoint, 50-100 MB. Full trainer state, 200-500 mallows memories. For 100 step training, saves at steps 50-100. Let's now look at loading from checkpoint. Resume training from checkpoint. Let's now look at configuration presets. Let's now look at preset 1, fast testing, 10 minutes. Here's the Python code for this section. Starting with training arguments. Use for testing pipeline, debugging. Let's now look at preset 2, standard training, 30-60 minutes. Here's the Python code for this section. Starting with training arguments. Use for most fine-tuning projects. Let's now look at preset 3, high quality, 2-3 hours. Here's the Python code for this section. Starting with training arguments. Use for production models, critical applications. Let's now look at Windows-specific settings. Let's now look at critical for Windows. 1. Use AtomU 8-bit optimizer. 2. Use FP16, not BF16, on Tesla P40. 3. Enable gradient checkpointing. 4. Don't use flash attention, not available on Windows. Unsloth handles this. 5. Set data loader workers carefully. Unsloth automatically handles most Windows quirks. Let's now look at testing configuration. Let's now look at dry run test. Test configuration without training. Here's the bash code for this section, starting with Sharpie testing configuration. Sharpie. Let's now look at configuration checklist. Here's the bash code for this section, starting with training configuration checklist. Let's now look at hands-on exercise. Let's now look at exercise, configure for your dataset. Your dataset stats from lesson 4.2, training examples, CIRCE, AVG token length, CIRCE, max token length, made easy to calculate. 1. Steps per epoch with batch size 4. Let's now look at key takeaways. 1. Learning rate 2E4. Good starting point for low rank adaptation on 3B models. 2. Batch size 4, grad ACC2, safe for Tesla P40. 3. 3 epochs, standard for 100, 200 examples. 4. Cosine scheduler, smooth LR decrease 5. Warm up 10 steps, stabilize early training 6. Atom W 8-bit, memory efficient on Windows 7. Evaluate during training, catch overfitting early. Let's now look at what's next. Configuration set. Time to actually train your model. Continue to lesson 4.4, training your first model. Let's now look at additional resources. Hugging face training arguments, learning rate schedules, gradient accumulation explained, Atom W paper. Lesson complete. That wraps up training configuration. Well done on completing this lesson. See you in the next one.